Well, good evening, ladies and gentlemen, and welcome to the Museum of London and tonight's Gresham lecture. Now, this Sunday coming, is going to mark the 50th anniversary of the world's first human heart transplant. I feel really privileged to have been performing heart transplants for a large part of my career. And after the tragic stories of the donors from whom we have to retrieve hearts, the miracle of seeing a donor heart burst into life after you've implanted it into a patient who's been terribly sick beforehand is truly awe-inspiring and one of the most humbling experiences a surgeon can have. Just imagine what it must feel like to receive a new heart when you've been sick. It's a bit different tonight. So in the first half of tonight's lecture, I'm going to give a brief history of how we got to the first heart transplant. But the second half of the evening is going to be a discussion where you will have the opportunity to ask questions of three outstanding guests. And these are my guests. First of all, Sir Terence English. Sir Terence is a truly great cardiac surgeon and one of the pioneers of cardiac transplantation in the UK. He's also former president of the Royal College of Surgeons, former president of the BMA, council member of the GMC, and master of St. Catherine's College in Cambridge. Secondly, Stephen Large, who has been one of the leading lights in British transplantation over the last few decades, and he has a deep knowledge of the subject and particularly insight into how we manage donors and what the future might hold. And thirdly, and I'm sure the other two wouldn't disagree with this, most importantly, Martin Barsby, who actually has a heart transplant, and he had it performed in 1991. He's an ex-journalist, now Director of Communications for the Office of the Police and Crime Commissioner in Norfolk, so watch out. And you're going to be able to ask questions of them. If you could start to prepare them and think about them, that would be fantastic. Now, humans throughout history have had fascination for moving body parts around, usually to make benefit of what skills animals had, as in the Minotaur and the Centaur and Medusa's head of snakes. And the classic is Homer's Chimera, which is part lion, part goat, and part snake. It's often used as a symbol of transplantation and regeneration. And there's been divine involvement in healing and organ or part replacement for centuries, with many references to replacing body parts throughout ecclesiastical history. Christ is reported to have reattached Malchus's ear after St. Peter had cut it off. Simon Peter had cut it off. It's quite good. And St. Peter himself is said to have reattached St. Agatha's breasts after a Roman soldier had removed them with a pair of pincers. Now, I must say, I think the soldier was rather a good surgeon to have made such a clean and neat job of it. But classically, it's the identical twins of Saints Cosmos and Damian, who in about 250 AD was said to have replaced the gangrenous leg of the custodian of a Roman basilica with the leg of a recently demised and recently buried Ethiopian gladiator who's on the right. Since the twins had actually been beheaded about a century earlier, it may be stretching credulity a bit far to think that they actually did that. And the artistic history is perhaps a doubt as well, certainly which leg was replaced and how extensive was the damage, and indeed the origin of the donor, who, as you can see, was a Moor in this rather than an Ethiopian. Now, some of the most important concepts in transplantation have come from skin grafting, which has been around for at least 3,000 years, where the Hindu tile makers used it to reconstruct noses which had been amputated as a punishment. It's a form of auto-transplantation where you move a piece of skin from one part of the body to another part of the same person's body. And Giuseppe Borrogno in 1804 studied this, but extended it just beyond moving skin from one place to another on a body to working with 27 animals of different species, including the same species as well. And he noted that autografts, which were grafts taken from the same animal and put somewhere else on that animal, survived quite well. But allografts, which were taken from the same species but put onto a different animal, did not. And xenografts, which were grafts taken from a completely different species and placed onto a recipient, were destroyed even more rapidly. Now, this was a long time before the science of immunology and the understanding of rejection were developed, but it was seminal work. And it formed the background to the development of further grafting during the First World War, where so many terrible injuries and burn injuries took place. And even then, few clinicians asked why allografts, even from a relative, failed, but the autografts they did, moving one piece of skin from the same patient, survived. So an American surgeon called James Barrett Brown, working in the military, also doing skin grafts, noticed that if you repeated that skin graft, the same patient needed another skin graft. The second graft didn't survive so well. And he was beginning to think that this must be some sort of immune mechanism, that you were reacting against the tissue. Now, Brown spent a little time in England during the Second World War and became fascinated by this problem of grafting and met a young Oxford zoology student called Peter Medawar, who was at that stage really working out what to do with his career. And he suggested to him that he might study skin grafts in humans. And that coincided with a time where Medawar was also approached by other people to look at burns. He was too tall to go into the army, and it was the recruiting board that suggested he tried to do something more helpful. He did become involved in skin grafting in Glasgow and in Oxford with Leslie Brent, who came over on the Kinder transport from Europe. He's seen here on the left, and they became really close friends and did some seminal work with Rupert Billingham. And between them all, they led to the recognition that there were genetic differences between the host and the recipient and different tissue responses. Brent, Medawar and Billingham became known as the Holy Trinity in this field because they were so powerful and so intellectually strong. And Medawar and an Australian called Macfarlane Burnet won the Nobel Prize looking at immune tolerance in 1960. Two wonderful photographs as well, I think. Now, I'd love to talk to you about transplant immunology, but it's hugely complex and way beyond the scope of this lecture. If you're interested, this is the book by Leslie Brent. It's a brilliant book, but the basic principles are these. We are different from each other and unique. The difference is manifest by different molecules or antigens expressed on the surface of each of our cells. If you put another person's cells into your body, they are recognized by your own body as non-self. And an immunological process of rejection to chuck those cells out is begun. And that can be acute, happening quickly, or chronic over time. And that potentially destroys what you transplant. Now, fortunately, those antigens, those markers on the cell surface, have been pretty extensively studied, and it's now possible to type tissue from one person to another and therefore to match it. And the closer the match, the milder the rejection, and the more likely it is that your transplant will take. We also know that that immune response can be modified by drugs. And it was the work of the Holy Trinity that really started the path to what became organ transplantation. Now, moving skin around is pretty easy. You scrape a bit off one place and you stick it on another place, almost literally. And but that's not the same with a solid organ like a heart or a kidney or a liver. They're fed and drained by blood vessels. And so one of the most important things that was required was to be able to join blood vessels together. And this was first managed, actually, at the end of the 19th century by Alexis Carrel, working in Lyon. And he took sewing lessons from an embroideress called Madame Leroudier and used oiled silk sutures on equally fine needles and developed this technique of stitching blood vessels together, which we still use essentially, although the needles are now smarter than they were then. Several other developments needed to come together before we might be able to transplant a heart. The first one of these I've talked about before in these lectures, which is cardiopulmonary bypass, the ability to preserve the function of the body while doing something to the heart, bypassing the blood going away from the heart. You had to, in some way, to preserve the muscle of the heart, and that was either done with cold or by paralyzing the heart using essentially a high potassium solution. You have to sort out how to do the plumbing. You can't just pluck it out of the sky. And you have to understand all of that tissue typing, how to prevent rejection, and post-operative care, which is going to be different in those patients from those that you normally manage. We'll talk briefly, I think, later in the discussion about the organizational skills and how much dedication is required to do this job. But then you need a logistics infrastructure which makes it possible to move organs and people around the country to make sure that you can actually get on and do the transplant. And finally, ethically, it's got to be appropriate. Scientifically, you've got to be sure that you've done the basic work. And it's got to be accepted by society. Otherwise, it's going to be a constant fight. And we'll discuss that too. Now, this is Walt Lillihei, who is often regarded as the father of cardiac surgery. He worked in Minnesota, which is where that red dot is, which is cold, a very cold place. And hypothermia and cold was one of the topics that they studied as a means of protecting the heart. He trained and influenced many cardiac surgeons who achieved fame in their own right, but 4 of them are crucial to this story. They are Norman Shumway, Richard Lower, Adrian Kantrovitz, and Christiaan Barnard. Now, the surgeons were the main players in what Donald McRae in this book called the extraordinary race to transplant the first human heart. It's a really interesting and excellent book. It brings a journalist's eye to the personalities, to the politics, and the science of the time. And he was right, it was a race, and it certainly was extraordinary. It coincided with another race, the space race, the United States and the Soviet Union. And indeed, at around the same time, there was a Russian called Vladimir Demikov, who was credited with performing many firsts in transplantation. The first heart transplants done in dogs in 1946, the first heart-lung transplants in dogs, and the first lung transplant as well, and the first liver transplant in dogs. But he became infamous, really, in 1954 for performing head transplants in dogs. This had actually been tried by Alexis Carrel in Chicago at the turn of the century, but this was really shocking to the community in the world. And in fact, it's been said afterwards that his role in contribution to this field has been underestimated, partly because he worked behind the Iron Curtain and partly because of these experiments. So let's get back to McRae's race. In lane 1, we've got Norman Shumway. And he joined the Minnesota team in 1949 and became interested in topical hypothermia. He was described as tall, witty, and engagingly laconic. He was a fantastic technical surgeon, but he was also thought of as the cleverest and funniest of the residents there at the time. He became very famous, but he always appeared to me as a sort of reluctant occupier of the limelight and quite shy. But I have really strong memories of a dry and ironic sense of humour, and he was always delivering his put-downs, which were frequent, with a winning smile, and was very charming. But he was a driven, and for the purposes of this talk, importantly, a very careful, very thorough researcher, and he continued to work on topical hypothermia, cooling the heart, in order that they could spend time operating on it. This is the 1950s. He got his PhD there, but in 1958 moved to Stanford in California. Okay, lane 2, Richard Lower. Richard Lower wanted to be a GP. He was a quiet, caring man, apparently. And he arrived in Stanford in 1957, younger than Shumway. But they soon met, and Richard Lower was conned, really, by Shumway to work with him on the same experiments and on the kidney machine at the time. They became known as Norm and Dick, not Norman Dick. And the skills of one amplified those of the other. And throughout the late 50s and into the next decade, they were working on techniques of stopping the heart for up to 90 minutes. And it suddenly became clear to them that actually if they could do this and it restarted without just doing anything other than flooding it with warm blood again, maybe they could take it out and put it back in the same place. Would it still work? And they did that. And it was a short step then to see if they could do transplants in dogs. And throughout the next decade, they really worked hard to achieve technical perfection and to understand ways of managing rejection. In lane 3 is Adrian Kantrovitz, who was working first in New York, moved to Brooklyn in 1955. A very creative man who was described by his bosses anyway as being difficult to work with, as many truly creative people are. And he worked largely on stray cats, so he moved away from dogs to stray cats to develop ways of repairing the mitral valve and mechanically supporting the heart. And he was one of the first people to use muscle. He used diaphragm muscle to make a booster heart to keep it working after transplantation. And then coming up on the outside in lane 4 was Christiaan Barnard. He went to Minnesota in 1955, but he went to learn esophageal surgery, not cardiac surgery, and only became interested in it when he was asked to look after the heart-lung machine. He went back to Cape Town in 1958 as head of experimental surgery in Gresham. Chris Barnard was described by his residents as aggressive, self-absorbed, and rather overbearing. And he began a rivalry with Norman Shumway, which is very relevant. Anyway, he came back. He crammed a huge amount of training into a short time because he had a brilliant memory. The three in the first 3 lanes were transplanting dogs throughout the early part of the 1960s. Lower moved to Virginia, and Kantrovitz carried on transplanting dogs in New York. And they did hundreds of dogs. And they had dogs that survived for up to a year after heart transplants. Chris Barnard had gone back to South Africa and became interested in transplantation in the early 60s. And he went to visit Demikov in Moscow, which was very unusual at the time, and then went to Lower's lab in 1966 to learn how to do the transplant. And he'd done 43 dogs, many less than the American teams, and none of them had lived for more than 10 days. But Barnard thought that he was ready to do a human transplant. And actually, Kantrovitz came quite close to doing it in a tiny baby in 1966, taking the heart from a child with anencephaly, born without a brain. But unfortunately, while they were waiting for the heart to stop, which they had to do, the quality of the heart deteriorated and they didn't go ahead. And the same thing in July. So didn't actually get round to doing the transplant. Norman Shumway was seen by most of the community, and even then I remember this, as being a leader. And he spoke to the American College of Surgeons and said, okay, we've cracked it. We've sorted out the physiology, we've sorted out the plumbing, and I think it's time we did a human heart transplant. In November of that year, Louis Baskansky was admitted in severe heart failure after 3 heart attacks, kidney and liver failure to, I'm going to ask my South African friends to pronounce this properly later, Grooteskoor Hospital in Cape Town. And he was considered a possible transplant candidate, and Chris Barnard, who was there, agreed. and he subsequently offered him a much criticised 80% chance of success. In late November, there was a potential donor, a young black man who'd fallen off a truck. It was a huge political and PR risk at the time. This was the apartheid era. But in fact, the donor's heart deteriorated too quickly for a transplant to take place. On the 2nd of December, 1967, the Darville family were in Cape Town, and the mother was called Myrtle, and the daughter, Denise, were hit by a drunk driver. The mother was killed immediately, and Denise suffered catastrophic brain damage. She went to Hoedspruit Hospital and had no brain activity, what we now call brain dead, and she had blood group O negative and was suitable to donate her heart to Vashkansky. Quite astonishingly, Vashkansky's wife, Anne, was driving past the accident when it happened. Her father gave permission for the heart to be donated, but there were no criteria for brain death in those days, and so you had to wait until the heart stopped beating when you withdrew ventilatory support to be able to do a transplant. The transplant was done by Chris Barnard, assisted by his brother Marius, who was also a cardiac surgeon, and a large team of 30. This is that operation. And the donor and recipient were taken to adjacent rooms, and they prepared the heart. And Denise's ventilator was switched off, and they waited for the heart to stop, ready to transfer. 40 years later, Marius Barnard, having kept this secret all that time, said that rather than wait for the heart to stop beating, he had persuaded Christiaan Barnard to inject potassium into the aortic root to stop the heart, which we now do routinely, but in those days was on the edge of ethical appropriateness. Transplant went on through the night, and he was finally taken off the heart-lung machine at 6 o'clock in the morning. Now, this was the race to do the first transplant had been won. The media around the world went completely crazy, and Barnard became a celebrity overnight and actually was born for it. It's difficult to imagine that you would see a montage like this in a newspaper these days, where you see donor, surgeon, and recipient on the same page of a newspaper. That's just not done like that. But it was a technical success, but all those who'd worked in the lab with those dogs over the time knew that this was just the beginning of problems. 5 days into recovery, a decision was made to give massive immunosuppression to prevent any rejection. And there was so much suppression of the immune response that a catastrophic infection of pneumonia occurred, and he died 18 days after his transplant. 5 days after his transplant, another baby donor appeared in New York, and Kantrovich, this is photographs from that operation, transplanted a heart into a little baby who lived for just a few hours. Barnard did the third transplant in January 1968 into Philip Bleiberg, a dentist. This was taken in the May of the operation in January, together in the car. It was a controversial operation at the time because he received the heart of a mixed blood patient, and there's quite a lot in the newspapers at the time about that. Bleiberg died in 1969 and published a really interesting autobiography which paints a picture of a man whose life and fulfillment were much better after the transplant than was expected. And he was well aware of the experiment that he was taking part in. He died, again, of rejection-related disorder. A few days after his operation, Norman Shumway, the man who'd done so much of groundwork to make this possible, did his first transplant on Mike Kasparek. Now, it wasn't easy, and he had to do 3 more operations, and Kasparek had 210 units of blood during that time before he died 2 weeks later. So you get a feeling that these early transplants were right on the edge of experience. They were life-saving operations for people who would otherwise die. It was a very emotional and difficult time. But the media storm was fantastic, and Barnard, who cannot be described as a shrinking violet, was photogenic, charismatic, confident. The media loved him, and he and the topic of heart transplantation were everywhere, a heady mix of celebrity, ethics, politics, and science. And unsurprisingly, those surgeons who'd lost out to Barnard in this race were, to say the least, a little unhappy about it because they'd put so much experience into it. When asked about it, Shumway said, "Does anyone know who was the second person to fly across the ocean?" It must have hurt. He needn't have worried about his legacy, though. I vividly remember reading about his first 150 transplants in 1979 in an article in the BMJ, a year after I'd started doing cardiac surgery, and thinking, God, that's really astonishing. I'm so humbling to hear about it. 1968, another South African, Donald Ross, who'd been a student with Barnard in Cape Town, performed the UK's first heart transplant, and by now the world's 10th, at the National Heart Hospital. And it was controversial. The donor was transported to the recipient hospital, and there was already a media presence when that happened. Franny Moore, who was a famous American surgeon, was there, and he wrote this: "The surgeons, in full operating regalia, appeared on the steps of the hospital to the shouts of cheering crowds, bands playing Britannia Rules the Waves and God Save the Queen. There was waving of flags, guardsmen in bearskin busbies hovering around on horseback. British Reserve was cast into the waves as Britannia rules." Public didn't take very kindly to all of this, and neither did the satirists. This was Private Eye just a few days later. And organ donation for other organs like kidneys reduced dramatically. And a group of transplant surgeons advised the government that intact donors, that is, a live donor, should never again be transported to the recipient hospital, and it's still the case now. That patient lived for 46 days before also dying of infection. It was difficult to find donors. There was no definition of brain death at the time, it was coming in. And even physicians thought, or many physicians thought, that heart transplantation, quotes, almost amounted to cannibalism. Ross performed 2 more transplants, but public and medical opinion was against him, and there was a moratorium against heart transplantation in the UK, and if you like, a decade was lost. Opinion began to shift in the late 70s. And then Sir Terence, who's sitting here in the front row, and you will meet in a minute, carried out the first transplant at Papworth, so that would be the 4th one in the UK. That patient died, I think, 17 days later. The technical plumbing problems had largely been resolved. And they've not changed much since, in a way. But the rejection and immunosuppression in those days with steroids and azathioprine remained profound. Tissue matching had got better, but it was still a bit of luck whether you got the perfectly matched organ, and the drugs were toxic and only partially effective, and excessive treatment might increase your risk of infection. So that drove huge amounts of research into improving anti-rejection therapy. And you've got to have a slide like this in a talk about rejection. The little red boxes are all the drugs that are interfering with this incredibly complicated process of cellular and humoral rejection. There's a bit more in the handout you can take away with you with sources if you want to read more about this. The result of all of this is that now if you get the transplant, this is the transplant survival through 1982 to 2015 worldwide, you have 80% chance of being alive at 3 years, 55% at 10 years, and 10% at 30 years. That's over 127,000 transplants. The problem with transplantation, which again I hope we'll discuss in a minute, is that the number of transplants performed worldwide has remained relatively static since 1990, around 4,000 and a bit. There's been a small and encouraging recent uplift, which we can maybe discuss. In the UK, this is the number of transplants done per year, under 200, a little bit of an increase over time. But the trouble is there are 250 patients on the waiting list at the moment, and Sadly, only very sick people get on the list, and even more sadly, some people die before they get the heart they hoped for. So the innovative drive and the drama of the last 50 years and those events of 50 years ago has resulted in many lives being saved and in significant scientific advances which have rubbed off on many other fields. It's all been about collaboration and cooperation, a bit further away from those competitive early days. And it's a tribute to everybody who's worked away behind the scenes and hasn't had the glory that attached itself to surgeons. But I think the real credit must go to the donors who altruistically, in advance, have thought of what they can do for others. And to their families who, at times of enormous sadness, have allowed the organs of their loved ones to be shared. None of this would have been possible without them, and all of us, I think, who do this work would recognize it. So I'm going to stop talking there, because what's more interesting, I think, is that you get the chance to ask the panel of Terence English, Stephen Large and Martin Barsby. I'm going to ask you, please, if you'll come up onto the stage. We'll change the lighting around, and I'll start asking some questions so we can get going from there. Thank you. So first of all, this is Martin Barsby.
Hi, Martin.
Good evening. Terence English. And Steve Large.
Martin. Hi.
Come and sit down, please. So, Terence, I'm going to start with you. By the way, my career in cardiac surgery is almost entirely, paediatric cardiac surgery is almost entirely due to Sir Terence, who turned me down for a job at Papworth many years ago, and I snuck under the radar. It's fair to say that you were there at around the beginning of all of this, and I wondered at what your memories of the personalities who seem larger than life in some ways, and the issues of the time, and whether you could reflect on those for us.
Well, of the personalities, I knew Donald Ross and Chris Barnard. And Donald Ross, when he heard I was going to South Africa on holiday in 1963, suggested that I call in at Cape Town and see what that mad chap Barnard was doing. They'd been contemporaries, and Donald had won the gold medal, which had got up Barnard's nose a little, I think. But anyway, I visited, and I wasn't terribly impressed at that time, Martin. He was getting very good results. He was an obsessional surgeon, but his technique left a lot to be desired when compared with Donald. And he used to get very excited and abusive at the operating table and so on. So I was somewhat surprised in 1967, exactly 50 years ago, when this was announced. But I knew that he'd been working on it, and I knew a little bit about Shumway's work. And Barnard's second case was what kept things going, I think, because he lived for nearly 2 years when all the others were dying much earlier than that. And if you look at the figures, there were, I think, 160 heart transplants done in the 2 years up to 1969. And about 10% of those, 1 in 10, was alive at 2 years. Somewhat different from your prognosis now. So things were not going well, and after the initial enthusiasm, they quietened down. And it was left really with 4 or 5 units in the world who continued to pursue this, of whom Barnard was one in Cape Town. But Shumway was the main driver at that time. One interesting thing about the two of them, on one of my recent visits to Cape Town, I visited the museum at Gresham, and they've now got a very good archive there. And in that archive, there's a most gracious letter written by Norman Shumway, dated 6th of December, 1967, 3 days after Barnard had jumped the gun, congratulating him. And to my knowledge, he never received a reply. And certainly, Barnard never gave him credit when he was going around America in the way he should have. So I became interested. Shall I stop there?
Yeah, I'll stop. No, carry on for a bit, and I'll stop you when I need to move on.
Well, I became interested in this when I visited Shumway's unit in 1973. I'd just become a consultant at Papworth, and I went to visit my friend Philip Caves, who was working there, had been a research fellow, and was then head of the transplant unit. And I was amazed to see these patients at Stamford coming back after some time and looking good. And Philip Caves was enormously enthusiastic about the future. So when I got back to England, I decided that it was time for Britain to have a heart transplant program, which would be really modelled on what Shumway was achieving and doing. And so I went back there fairly frequently over the next 5 years, and I prepared for us to do it here. And there were three important things that happened before we started. One was that in 1976 there was an important report by the medical royal colleges on brain stem death, and they defined how this should be diagnosed, and they equated it with death of the patient. And the important thing there was that these were patients with very severe cerebral damage, but it had knocked out the brain stem with the respiratory center, and they had to be maintained, their circulation, on a ventilator. And they would last on a ventilator for a week or two and then die inevitably. But while they were on the ventilator, their heart was still in good condition. And these provided a new source of supply of potential donors, which was very important at that time, particularly for us at Papworth, where we were looking to try and bring, to get donors from all over Britain. The second thing was the good results that were coming out of Stamford. You've mentioned the 1979 report. That's what we modelled ours on, to try and achieve their sort of results in 1979. And our research was mainly directed towards how best to preserve the heart between when we took it out from the donor and transplanted it in the recipient. So with those three things, in 1978, and knowing about the moratorium that Martin has mentioned, I presented our protocols to the Department of Health and said we were ready to go and start a program. I was listened to quite politely, and then 2 weeks later got a letter from the Sir Henry Yellowlees, who was the head of the department at the time, saying, well, sorry, Mr. English, no money for a program, and we don't want to see you do any one-off transplants. Now that was a nice challenge, because I'd done all this work over 5 years and I really wasn't going to stop. So we went to the Area Health Authority, and the chairwoman, who was a very interesting lady, she agreed to me using my facilities at Papworth for 2 cases. And we went ahead and we did the first case, and it didn't work. It was very complicated problem. I won't tell you about it. But the roof fell in, and the criticism was enormous, because there was already a lot of anxiety about restarting this, which hadn't worked in Britain 5 years earlier. However, we had, and there's criticism from the medical profession as well as the Department of Health. I had to go and give an account of this. But 4 months later, we did our second one, and Keith Castle lived, and he lived for 5.5 years, and he did more for transplantation than I ever could have done, because he lived an extraordinary life. He was a lovely builder from Wandsworth, a Cockney with a wonderful wit who did a lot of cycling, and he showed how good a life after transplantation could be. And that's what we needed at that time. We collected money from all sorts of areas after those first 2, and then the department started putting in a bit of money, and we then expanded really very rapidly and got colleagues like Steve Large and so on to help with it.
I think that's a really good moment to switch to Martin and ask you a sort of fairly obvious question. I mean, what's it feel like to have someone else's heart in you beating away?
Obviously, the challenge for me is I don't know what it feels like anymore not to. I've lived with a new heart for 26 years. I had the transplant when I was 20, So I obviously lived a lot longer than I with the transplant than I did before. And apart from a regime of tablets every day, talking about the immunosuppressants, and then there's tablets to counteract the tablets, and it's a nice regime, but it's a set regime. And apart from that, I mean, whatever a normal life is, I suspect that's what I'm living, and I don't feel any different. I live in what a normal life would be. I get up. I wouldn't say I get up on a Monday morning, leap to the curtains, draw them open, and say, "Wow, look, it's wonderful to be alive." I would say, "No, it's Monday morning. I've got to go to work." So if that's normal, but I think that is a success, isn't it? That for me feels like a good thing, and that feels like some kind of normality. My wife is here tonight, and my daughter was 16 earlier this month. So I think there's something about those bits of life which I can't say whether I value them more or less than another 47-year-old just in a different position.
And do you reflect back on that time at all, about around the time of the transplant? Do you remember it, and what are the things that you recall and feel that people might like to know about?
Well, I remember actually quite a lot of it quite clearly. Some of it is vague. I do remember the last time I think I saw Steve Large was him in his surgeon's gear, coming in to talk to me about the kind of hard facts. And I'd asked Steve to sort of give me the straight facts and not give me any soft soap, and he absolutely did that, I'm afraid. And he said to me, I said, "Well, what if I don't have it?" And he said, "There's a 50% chance of you living 6 months." And that's what I needed to hear. So there wasn't really that much choice left for a 20-year-old. I mean, I, at that point, didn't have a mortgage, didn't have a wife, didn't have a daughter. So just a different set of circumstances. But I do remember, and I think, sitting here tonight, listening to your lecture, it is hugely humbling, and I feel quite a small part of that. I mean, the wonderful work everyone has done just to get to that point, which put me in that position. But I think the thing you said that really hit home for me was the importance of the donors, because without that element, the rest is an irrelevance. So that bit for me is the bit where of course I'm grateful. If I said I was getting up every day and thanking the donor, again, I'd be an absolute hypocrite. That's not how it is. But I think there's a difference between being appreciative and hugely appreciative, recognising that fact, but not maybe dwelling in the past, but maybe pushing forward and having a look into the future and looking at a positive kind of attitude in that respect. So whether that's all shaped by the experiences in the transplant, I'm not really in a position to say, because I didn't live the other parallel life. So
let me turn to Steve, if you don't mind. So, I mean, one of the striking graphs, I think, from what I showed earlier is that the number of transplants done is the same as it was when Martin had his transplants. It's fundamentally still around 4,800 in the world. 25 million people have heart failure in the world at any time. There's this enormous mismatch between supply and demand. You've done quite a lot of work in your career to increase that donor supply. I think it would be very interesting to talk, if you don't mind, about that challenge, how to preserve more donors, get more donors, and change that equation.
I mean, I have to say, it's a very humbling moment to be here with my mentor, who I was in London having a great time. I was sent up to Cambridge because they were doing dodgy things in Cambridge, and
they still do that. Yeah.
And I've never left. That was 35 years ago, and it's a wonderful thing. But the problem is that we've got an aging society, and there's more of us, and so the pressure for an age-related problem, which is heart failure, is going to be burgeoning, increasingly difficult to meet that demand with, happily, and I say this in front of Martin Busby, happily with reducing numbers of donors, because it's a tragedy. Every transplant is associated with that tragic loss, that amazing gift. It's an extraordinary thing. But what we've done is to originally look at the heart-beating donors that Sir Terence and his his amazing colleagues and the pioneer of all of this, looked at, and there was a clear definition of brainstem death, which was a great step forward. But death brings about a hurt to the heart, hurt to all the organs. We don't really understand precisely what that injury is. It seems to be transitory, but of all the donations, we only use something like 1/3 of the hearts that are offered, and that's desperately upsetting, because so many folk have such expectations, the recipients, but of course also the donor family. So there's lots of work to do in that area, and we're beavering away trying to increase that 30%, that 1/3 or so, to 50% or 60%. So we've got people working on the way to try and find a way to get a greater recovery from those beating heart donors that we get. But what we saw as the hideous picture that Martin Elliott has shown, where we've got the supply, the activity pretty static, the waiting list going up and up and up as we expected. We saw that colleagues in liver and kidney transplantation were saying, look, we can actually take organs from folk whose hearts have stopped and who wish, their final wish was to become an organ donor. And so they felt that they were realizing that wish. And we had a battle, and I have to say that two people have been wonderful in that battle to get heart donation from non-heart beating donors, which has been an extraordinary history, a sort of micro history of what Sir Terence has been through. And I have to say, I've lent very heavily on Sir Terence to guide me through the political process. I am certainly not a skilled politician. Sir Terence is, and he's kept me relatively on the straight and narrow. And we've started the program of taking hearts from non-heart beating donors to fulfill, the winning phrase was, to fulfill that final desire for that individual, should they die, to become a multi-organ donor. And as a result, we've managed to increase our activity by 30%. It doesn't sound much, but for every individual that we do transplant, it's a phenomenal turnaround. It's just wonderful. And Martin is a credit to the system. We reckon there's a 50-50 chance, I don't want Martin to listen to this, of surviving 13 years after heart transplantation. And Martin has blown that statistic out of the water, thrown me to the wolves of pessimism. But what we need to do is to find some solution, some perfect solution that can meet the rising demands of heart failure.
Right, you've heard enough of me driving this. I think I'd like to open the questions to the floor. And let's start here at the front. There's a microphone coming down. And if you could just wait for a moment.
Brilliant session, thank you very much. Philip Bleinberg, who was the second candidate, wasn't he? I was fascinated, that's the wrong word, he died 18 months? And he had him after 18 months, I think, is that correct? 20 months. I just remember that figure, is that not right? Anyway, the point was that he received the heart of a young person, and I presume it was a normal heart. But after 18 months, the heart transplant was full of atheroma, as Bleinberg had been anyway. And it's difficult, isn't it, to actually be selective enough every time. Because if they're a candidate for transplantation, they may not get a good result anyway because of their own pathology, if you know what I mean. I don't know what you feel. Do you feel anything about that?
Yes, I mean, this was something we came to recognize fairly soon in our experience, is that you could take a heart from a young person that was without coronary artery disease, transplant it into a patient, and then after a period of a year or 2 or 3 or 4, they developed a slightly different type of coronary artery disease, but a narrowing of the coronary arteries. And this was clearly a reflection of the immune process, which was attacking the walls of the vessels. And so it's interesting that it's not happened to every transplant patient. It's been fairly selective, but it does happen. and it's a reflection of the immune response. And that's what Bleiberg died with.
Let's see.
So the second question we've got actually come from the internet stream.
Okay.
Basically, they were interested in the what you were talking about, the Russian who'd transplanted a dog's head onto another dog's body. And I think the question was about what is the potential for that in humans, and potentially where might we be looking next for further developments in transplant surgery?
Well, there is an Italian surgeon who is busy trying to get clearance to do a head transplant in humans, which still seems to me to be on the edge of science fiction and the edge of ethics and morality. I don't know what you gentlemen feel.
Well, I disapprove of it, actually, because it is so unlikely scientifically to work, to have to transplant the spinal cord. That is a very delicate neural tissue. But so I don't think it's got a future, and I don't think face transplants have much of a future either, because they are very immunogenic because of all the skin that's transplanted, and they probably won't last all that long. But where the future does lie, and it's always been in the future, as Shumway used to say, is what's called xenotransplantation. And this is where you use an organ from an animal, such as a pig or indeed a primate, to treat in a particular way and manipulate its genetic structure so that it is far less immunogenic when it is transplanted. And there's a lot of interest been going into this for a long time now, but there is a new Xenotransplant Institute that's just been established in University of Alabama in Birmingham, and they reckon that they'll do the first kidney xenotransplant this next year. And if that goes well, hearts will follow.
The other thing that we perhaps need to mention, I have discussed here before, is the rise of the machine, is that an increasing number of people are supported on left ventricular assist devices and occasionally on complete heart replacements for an ever-increasing amount of time. And indeed, in America, some particularly older people, are choosing to have a device to support their heart rather than a transplant because of the drugs that Martin mentioned earlier. And so there'll be a borderland of that area of machine versus donor. And I think the other thing that is also being tested extensively is taking the diseased heart and injecting into it stem cells or modified stem cells, which can potentially remodel or regenerate muscle within the heart and change its function. So there are little areas on the edge that people are trying all the time. I think there was a question here. I'm sorry. You do.
I just wanted to say well done for all the progress that you've been making. How do you prioritise who receives a heart transplant? Because you could look at smokers and say that, oh, they don't care about their health, why would they deserve a heart? But that's not like, as a doctor, you want to help them, you want to save them, so how should people be prioritised?
Can I answer that? Because it was one of the big issues that one had to try and be clear about, first with yourself and then with the patients who were referred to you for assessment. And what we did, in fact, was to keep a list of the donors, the recipients who were waiting, who'd been assessed by us, accepted for a transplant, and they were put on a list. And they were put on in the order that we accepted them. Now, they each, on that list that I carried around with me, each of them had the age of that patient, his weight, and the blood group. And if we got a common blood group for a donor, like an O positive, it was often difficult to decide, but it would go normally to the first person on that list, unless we knew that there was another person who was either waiting in our hospital or in another hospital who had been informed about was deteriorating fast, and really needed that heart. So it was an arbitrary decision, but it was made with the best will and the best information that we had. And I would explain this to patients when they came for assessment, because they were always worried about this when they went home. And we had a wonderful social worker with us, and she would keep in touch with them and let them know how things were, and they were always able to phone her and find out where they were on the list. It was a difficult problem.
Lists are now managed across the country. There's a big infrastructure, and they are managed on urgency and on matching as the two criteria. Increasingly, particularly in the paediatric population, you essentially have to be supported on a machine first before you can get a transplant, before you reach that urgency because of the shortage of donors. So your question is very, very valid. I don't think the lifestyle comes into it quite as much as the quality of the cross-matching and the severity of your disease. So to put your mind at rest about that, I think.
It's interesting. One of the things I do remember is the last couple of weeks before I had my transplant, thinking how wonderful. I mean, the staff were absolutely fantastic at Papworth the whole time, but that last couple of weeks, looking back, I can remember being looked after extra well. Now I know why.
So you're here tonight.
Yes, but it was, now I think back, it was whatever I wanted for lunch. I even remember them getting a chair so I was comfortable, and I was just thinking, this was, aren't they all just superb? Now I look back, I think, well, yeah, that was probably because I was not far off.
Yeah,
So,
your last meal.
yes, it was, yes.
So a question on the front, yes.
Hi, my name's Katrina and I'm a pharmacist. I just had a question for Martin. Having taken immunosuppressants for 30 years, what's the worst thing about those drugs for you, and would you be happy to share which ones you're on?
Yeah, I've got to remember them. Yeah, the immunosuppressants are sirolimus, or sirolimus, I've got to pronounce them properly now, Martin. Prednisolone, pravastatin, and I've got to get that. Was a Tenlon, it's now bisoprolol. See, I'm terrible. But I think part of the good thing is that I don't remember, I just do them every week and put them all in. Now, in terms of side effects, not many. Prednisolone I forgot as well. That's obviously an important one. So in terms of side effects, not many that I could talk about. Occasionally you might get a bit of stomach ache around lunchtime, but that's probably just because I'm hungry. But those drugs, interestingly, are not the same ones I started on. So the ones that I can remember, Cyclosporin from the early days, they're now no longer. I think probably nearly all the drugs that I'm now on were not the ones I was taking at the start. And I did have episodes of rejection and infection at the start, as is expected. So I don't think there was anything unusual in those early days. But the ones I'm on now, it's just, and it is interesting because it's a case of 10 o'clock. 8 o'clock, 10 o'clock, 10 o'clock. So that's just routine. So they're in my pocket at 10 o'clock tonight, I'll be taking those tablets. It's now around 15, it was around 30, 40 in the early days as well. So just again, they're all different, all moved on.
Let's take another question. I think I can see one hand up at the back, and then Sarah, you next. So lady there, and then back.
My question's for you, Martin, as well. I was just wondering what was most helpful for you in terms of decision-making around the transplant. I appreciate what you're saying, it's a while ago, but that and also preparation for transplant. And what was most helpful for you in adjusting to life after transplant as well? Sorry, it's a bit of a three-parter.
No, that's fine. In terms of the actual transplant decision, and even now I look back and I think actually there was pretty much no decision. I mean, people will say, oh, that means you must have been so brave. I don't remember an element of bravery about any of it. It was a case of survival. So with Steve's assessment, which again, you got to thank him for that honesty, that it was, it's 50% chance of living 6 months if you don't. And if you do, the heart I received, obviously hugely grateful, was never perfect, has never been. It was a no decision. And I said maybe that decision was easier because at that time I was a 20-year-old undergraduate. I wasn't in the position I am now with family, mortgage, etc. So maybe again, there's an easier decision there for a 20-year-old who's single and at university. Afterwards and the aftercare, again, I come back to the fantastic team at Papworth and family. You know, family, I think I've said before, Martin, was the foundation and still is. I'm very, very fortunate to have the most fantastic family. And they were there. I think it was probably harder for them at that time to go through it because I was, well, frankly, during the worst bits, I was asleep or out for the count, shall we say. And they were wonderful, still are, and hugely supportive. So it's a combination of those brilliant staff at Papworth and family is the answer to that piece of the question, and I think I've only answered two.
Yeah, it's just thanks to you and also the preparation for the actual transplant. Once you made the decision.
Once I've made the decision, it was all pretty swift. And again, I come back to the answer I gave earlier, that I think now thinking back about how ill I must have been, because it was all, and I can't remember much about that if I'm brutally honest. The bit I remember is being asked to count to 10 and getting to about six and a bit. And then the next thing I remember is waking up in sort of a...
That's what we do with Steve every time before we operate.
So I don't
What's
remember
the sixth thing that you're talking about?
Let's take one more question from...
The
yes,
tenor I
that
slipped
gentleman
you,
with
Martin, has
Yeah.
obviously gone down well. Yeah.
Hi there. Thanks for a great talk. My question is also for Martin. Sorry to leave you all out.
That's good.
There are obviously going to be a lot of people watching, considering whether or not they want to donate. And obviously it's a big thing going through at the moment,
Of
whether
course.
or not people are included in donation,
Yes.
or whether or not it's an opt-in service or not. I'd like to know, do you know anything about your donor? And if so, what would you say to people watching perhaps on the YouTube feed or in future, if they're considering donating, what would you say to those people?
Well, I'll give an honest answer to that question, that I did not carry a donor card when I received my heart. I wish I had. What I would urge people to do is to think about it, have that conversation with family and friends, and to get on the register if that's what they as an individual feel that they are willing to do. Steve has made a very eloquent point, obviously, about the numbers of donors that are needed. So obviously my plea would be to have that conversation. I think that is, for me, as important, is to have that conversation with family and friends, and to be on the register.
Can we, does everybody understand this business about opting in and opting out? So if I just ask the question just of this audience out of interest, who believes that you should opt in? In other words, that the assumption is that you are not a donor and that you have to opt in a system. Who would prefer that? Let's put your hands up for that one. And who would be an opt-out? In other words, that it's assumed that you're a donor and you have to carry a card that says, I don't want to be one. It's very interesting, isn't it? Very interesting.
So I hope that answers
And there's
the question.
a new law in Israel and one in Canada as well, which are saying that your prioritization, to go back to your earlier question about who gets a transplant, if you carry a donor card, you have a higher priority on the list than if you don't in those two countries. And that has already increased the number of transplants being done and also the number of donors, I think.
So I didn't, but if someone hadn't, I simply wouldn't be here. So that's the maths.
Okay, we can do one more question. I think that I can see this gentleman here. The light's not perfect.
This question was to Martin again. Sorry.
Okay.
It was just that you were saying that for the immunosuppressants, obviously they have side effects, and you were saying that you take tablets to counteract those side effects. I just wanted to know, like, what those tablets were and how do they actually work from like a more biological perspective.
Cool. That's
Well, I have to pass on to
highly technical question.
Patients.
No, I'm going to get myself in real trouble here. One lansoprazole, for example, to settle. Am I all right, Steve?
No, you did
I'm
great. You did great. Way ahead of me.
Oh, I'll tell you. I need that slide back up. Again, just to counteract some of the toxic effect. I'm going to keep going, talking about that toxic effect of some of those other drugs, so just to settle the stomach and to counteract. That's where I'm going to stop.
The more modern drugs have a more precise locus of activity, and so their side effects are have reduced because they're not acting in a number of multiple sites, you see, particularly things like sirolimus, for example.
And steroids, which is really what you're hinting at with the lansoprazole, can bore holes in the stomach, for example. But a big nightmare in those early days when you had a young recipient and a little bit worried about their appearance. And occasionally, patients would take themselves off, recipients would take themselves off their immune suppressant. And that was heartbreaking. And then you can run into huge problems with acute rejection. And indeed, sometimes it's fatal. So a huge pressure on those of us interested in the area to try and improve on the immune suppressant drugs so that there aren't these tricky side effects that discourage people from taking their drugs.
Well, I'm sure we could all like to carry on this conversation all evening. I certainly enjoyed you being here. I'd like to thank Steve Large, Sir Terence English, Martin Barsby for joining me tonight. Thank you very much.